Hello and welcome back to our class notes. We are on 9-9, Introduction to Stoichiometry. This is our second video. In our first video, we took a look at one of the charts we saw several units ago, how to convert a substance to different things. But this chart dealt with always converting like a volume of water to moles of water, or a number of molecules of water to moles, or this chart dealt with how much you have 36 grams of water, how many moles is it? It was always dealing with one substance. But now that we know how to use chemical equations, we realize that if you know anything about one substance in a chemical equation and you have the chemical equation, you can find out anything about any other substance in that chemical equation. Our first example problem is going to be involving one of the most common problems in all of chemistry, mass-to-mass stoichiometry. Again, stoichiometry just means you're going to use the chemical equation in a vital step. In this problem, they'll give you the mass of one thing, and they will need to know something about the mass of another thing. That will involve this blue arrow, the mole-to-mole conversion. Let's take a look at such a problem. Solid lithium hydroxide is actually used in spacecraft to remove exhaled carbon dioxide from the air. Here's how it happens. Lithium hydroxide will react with the carbon dioxide in the air, and we end up producing lithium carbonate and water. When we balance the equation, we see that it's 2 moles of lithium hydroxide are needed to remove 1 mole of carbon dioxide. Our very first problem, how many grams of carbon dioxide can be removed from 100 grams of lithium? So our given here is in red. On this chart right here, the red side is the given side. The question that we're trying to find, how many grams of carbon dioxide, that's highlighted in green because that is a different substance that we're trying to find something out about. So, what did they give us? They gave us the mass of one thing. And they're asking for the mass of something else. So when we look at this chart, they gave us the mass of one thing right here. And they're asking for the mass of something else. We can do it. It will involve 1 conversion, 2 conversions, 3 conversions. The first conversion we already learned to know. We know how to convert the mass of one thing to the mass to its moles. So in that first step, we're going to need to convert 100 grams of lithium hydroxide to moles of lithium hydroxide. And that's what they're going to do in our very first step. In our second step, we're going to use the balanced chemical equation. It says to convert mass of lithium hydroxide to moles of lithium hydroxide, we need to know the molar mass of lithium hydroxide using the periodic table of elements. Molar mass of lithium hydroxide. We learned how to do that. This is what they're doing right here. They're adding up the molar mass of lithium hydroxide. Lithium hydroxide has 1 mole of lithium. 1 mole of lithium is 6.94 grams. There's 1 mole of oxygen. 1 mole of oxygen is 16 grams. And there's 1 mole of hydrogen. 1 mole of hydrogen, 1.008 grams. So the molar mass, if we add these 3 numbers up, the molar mass of lithium hydroxide is 23.948 grams. We learned earlier this year that we can always express equalities in 2 ways. We can put 1 mole over the mass, 23.948, or we can put this side over this side. Which of these 2 conversion factors will I need to use? Mole on top or grams on top? If we come right back up here, this little conversion factor is telling us to pick the one with mole on top. Here we go. This is the one with mole on top right there. So we're going to use this conversion factor right here. Why is that? Our given is 100 grams of lithium hydroxide. Right there. That's our given. We've got mass on top, so we need it on the bottom, so that dimensional analysis or the factor label method will allow us to cancel that out. And we are now at moles of lithium hydroxide. So we're right here. We're on the chart. We're right here on moles of lithium hydroxide. We're trying to find mass of carbon dioxide. So the only way I can go from moles of one thing to mass of something else is to first do the mole-to-mole conversion. It tells us to put the moles from the chemical equation of the thing we're finding on top and the coefficient from the moles of the chemical equation of the thing we're given on the bottom. So we need inequality. It's 2 moles of lithium hydroxide for every 1 mole of carbon dioxide. I can write that 2 ways. I can put 2 moles of lithium hydroxide on top and moles of carbon dioxide on the bottom, or I can put moles of carbon dioxide, the thing I'm trying to find, on top, and 2 moles of lithium hydroxide on the bottom. Those are the 2 conversion factors I can get out of this. Which one do I want? I want the moles of the thing I'm trying to find on top. The one I'm trying to find is carbon dioxide. That's what I'm trying to find. The question's asking about carbon dioxide. So I need this equality. Mole of carbon dioxide on top, 2 moles of lithium hydroxide on the bottom. And to be sure I need to know that, I just let my dimensional analysis or factor label method check it. I've got moles of lithium hydroxide there. I need the one with moles of lithium hydroxide on the bottom. That's this conversion factor right here. Now we are in moles of carbon dioxide, and I want to know the mass of carbon dioxide. So to do that, I need the molar mass of carbon dioxide. Right here. I need the mass of carbon dioxide from the periodic table on top. I need moles of carbon dioxide on the bottom. I look at my periodic table. Carbon dioxide has 1 mole of C in it. 1 times 1201 is 1201. There's a 2 after the O, so that's 2 moles of O. 1 mole of O is 16 grams. 2 times 16 is 32. 12.01 and 32 is 4401. I can write inequality 2 ways. I can put moles of carbon dioxide on top and grams on the bottom, or I can put grams on top, 4401, and moles on the bottom. Inequality allows us to put either one on top. Which one do I need? If I forget, I just look up here on the chart. I need grams on top. So I'm going to pick the one with grams on top. There it goes. The other way I can check. This unit is moles of CO2. There's moles of CO2. I need it to cancel out. The only unit that didn't cancel was grams of CO2. That's the unit I'm trying to find. So I take 100 divided by 23, or 23,948 equals, divided by 2 equals, times 4401 equals. 100 grams of lithium hydroxide can remove 91.89 grams of carbon dioxide. That's one of the most fundamental calculations of all of chemistry, mass to mass. What happens if they ask for something other than mass, such as in problem number 2? How many molecules of water would be produced from 100 grams of lithium hydroxide? So our given again is 100 grams of lithium hydroxide. Our given side is in red because it's on the red side of the chart right here. They're still giving us 100 grams of lithium hydroxide. However, this time they're asking for a quantity count. They want to know how many molecules of water would be produced. There is no shortcut here. The only shortcut to quantity count is from another quantity count. I'm not at a quantity count. So what I want to do is go mass of lithium hydroxide to moles. Then I want to use the chemical equation to go moles of lithium hydroxide to moles of water. And then I'm going to want to use this conversion, Avogadro's number on top divided by moles, to get me to the quantity count. We've already done the first step, mass to moles. That's the same identical thing that we did in this problem right here. We did mass to moles in this problem right here, it'll be the same thing. Our first step, we're going to go mass of lithium hydroxide. We're going to convert it to moles by multiplying by 1 mole over 2398. Same exact thing we did here. Grams times 1 mole over 23.98. Why? The only thing you can convert mass to is moles. That step, if they give you a mass, that step would always be the same. That's our first step. Our second step, we're going to use the mole-to-mole coefficients. We're going to use the coefficients from the balanced chemical equation. The moles of what we're trying to find will be on top. The moles of what we're given will be on the bottom. So I've got to take a look at our chemical equation right here. It's 2 moles of lithium hydroxide for every 1 mole of water. So I set up my equality. 2 moles of lithium hydroxide per 1 mole of water. 2 moles can be on top, lithium hydroxide, over 1 mole of water on the bottom. It's an equality, so I can put 1 mole of water on top. 2 moles of lithium hydroxide are on the bottom. Those are the 2 conversion factors I can get out of this. Which one should I pick? I want the one with what I'm finding on top. So the 1 mole of water should be on the top. I need this one. 1 mole of water on top. What I'm given should be on the bottom. That's 2 moles of lithium hydroxide on the bottom. How do I know that's right? Well, on this conversion, I have moles of lithium hydroxide on the top. I need it to cancel out with that one, moles of lithium hydroxide. Grams of lithium hydroxide canceled with grams of lithium hydroxide. Moles of lithium hydroxide will cancel with moles or factor out with moles of lithium hydroxide. I'm now at moles of water. So where am I on the chart? Moles of water, right here. Moles of what I'm trying to find. But I'm trying to get the quantity count, the molecules of water. So I need Avogadro's number. 1 mole of anything is 6022 times 10 to the 23rd. So my third step is going to be entirely different in this problem. First step was the same. Second step was the same idea. We just had different, we had 1 mole of water to 2 moles of lithium hydroxide. My third step, 1 mole of anything is 6022 times 10 to the 23rd. Here it's been rounded to 602 times 10 to the 23rd. I can put mole on top, quantity count on the bottom. Remember, on your calculator, it's always smart if you enter Avogadro's number to use parentheses, especially when you're dividing by it, so that you do not have an order of operations error. The other way I can express this equality is to put 6022 times 10 to the 23rd, or round it to 602 times 10 to the 23rd on top. 1 mole of water on the bottom. This is the one I need right here because I want Avogadro's number on top. There it is. The way I can check that is if this one is moles of CO2, that has to be moles of CO2. Oops. If this is moles of CO2, if this is moles of H2O, that has to be moles of H2O so that they cancel, leaving me with molecules of H2O, which is what I'm trying to find. So grams cancel with grams. Moles of lithium hydroxide cancel with moles. Moles of water cancel with moles of water. I'm left with the unit molecules of water, which is what I'm trying to find. So I would take 100 divided by 23.948, hit equals. I could divide that by 2, hit equals, and then multiply it by Avogadro's number here. It's 602 times 10 to the 23rd. This has 3 numbers, so I want to round to 3 numbers there. If I did 6.0222, then I could keep another number. I don't know why they did not go 6022. And that would come out to 1.26 times 10 to the 24th molecules of water. Folks, on this chart, we can go anywhere. They couldn't have asked us for volume of water, or they could have asked us perhaps for volume of water, but here it's a liquid. So that only works, volume only works with gases. We'll be working some practice problems, or we'll be doing some problems with this. Good luck.